In this video, we're going to graph linear functions by using the x and y intercepts. So for this example here, we're going to find the x and y intercepts for this particular function algebraically, and then we're going to plot them on our graph and use them to help us graph our function. So if you take a look here, our x-intercept is the first thing we're going to find. And remember, our x-intercept is a coordinate point where we cross the x-axis. And what we know about all of the points on the x-axis is that y is equal to 0. So our goal as we're finding our x-intercept is we're going to find the x value when y is equal to 0. So what we're going to do is we can take this original function here. So we have 4x minus 8y is equal to 24. And we're going to replace y with 0. So here I'm going to write 4x. I'm going to use keep change here just to make sure I don't make a sign error. I'm going to replace y with 0. I then know that negative 8 times 0 is 0. So I know that that's going to result in nothing. So we then have 4x is equal to 24. We then need to divide by 4. And we find that our x value, when y is 0, our x value is 6. And so what that's telling us is that our x-intercept point for this function right here occurs when x is 6 and y is 0. And this is the coordinate point where we cross the x-axis. So what we can do is we can actually go to our x-axis and go to x's 1, 2, 3, 4, 5, 6, and we can plot and label. So we have x is 6, y is 0. That's the x-intercept point for this particular function. Now, let's flip things around and let's find the y-intercept point. Remember, the y-intercept point is where we cross the y-axis. And what we know about all of the coordinates on the y-axis is that all of the coordinates on the y-axis have an x value of 0. And our goal is to find the y value when our x value is equal to 0. So we're going to go through this same process. So we have 4x minus 8y is equal to 24. I'm going to replace x with 0. So I have 4 times 0. Then I'm going to use keep change here so I don't make a sign error later on. I know that 4 times 0 is 0 or nothing. So that's just going to result in a negative 8y is equal to 24. I then divide by negative 8, and I find that my y value is equal to negative 3. So when x is 0, y is negative 3. And there's my next coordinate. There's where I cross the y-axis. X is 0, y is negative 1, 2, 3. So I can plot and label that point. Now, these are 2 points that are important to my line. They are the x-intercept and the y-intercept of my line that is formed by this equation. So what I can do at this point is I can connect these 2 points using a ruler, and then I can draw my line fully extending it through both sides of the graph. And so really, if I can find 2 coordinates on my line, in this case, the x-intercept and the y-intercept, I can create an entire line graph for my function. So you can see here we have our x-intercept plotted, our y-intercept plotted, and we connected them with a ruler and drew a nice straight line. Now, we can also identify the domain and the range of this graph. And because the domain and range represent, the domain is all of the x values used to make this graph, and the range is all the y values used to make this graph, because this graph is going forever left and right, our domain is all real numbers. And our range, because this graph is also going forever up and down, is also all real numbers. So now let's take a look at another example where the equation is written in a slightly different way. So for this equation, we are also going to find the x and y intercepts for the function. So you can see the function is right here. And then we're going to use those 2 coordinates to graph the function. So the first thing I need to find is my x-intercept point. Remember, my x-intercept occurs when I cross the x-axis. And all of those coordinates along the x-axis contain a y value of 0. So my goal is to find x when my y value is equal to 0. So we're going to take this equation right here, and we're going to replace y with 0. So we have 0 is equal to negative 3x plus 6. And now what I need to do is I need to solve for x. So I need to get x completely by itself. So I'm going to start by subtracting 6 on each side. So I have negative 6 is equal to negative 3x. Then I'm going to divide each side by a negative 3, and I end up with x is equal to 2. So this is my x-coordinate for my x-intercept. So I now have my x-intercept where I crossed the x-axis, and I can plot it on my graph. So I have x is 2, y is 0. So x is 2, y is 0. Now let's focus on finding our y-intercept. Remember, this is also a coordinate point, and it's the coordinate point where we cross the y-axis. And we know from talking about the y-axis that all of the points on the y-axis have an x-coordinate of 0. So we're going to find y when our x value is equal to 0. So let's take our equation. So we have y equals, and we're going to replace x with 0. So we have negative 3 times 0 plus 6. Well, I know negative 3 times 0 is just 0. So here I can see that my y value is 6. So when x is 0, y is 6. And this is where I cross the y-axis. So if I go to the coordinate x is 0, y is 1, 2, 3, 4, 5, 6, I find my y-intercept point. So now what I can do is I can connect these two coordinates and fully extend my graph with arrows to show that it continues on forever. So I can extend and connect my points and then extend all the way through the coordinate plane. So if I can find just those two coordinates, the x and y-intercept, I can create an accurate graph for this function. Then from here, if I want to, I'm also able to identify the domain and the range. Remember, domain are all of the x values that we need to make points on the graph. So for this example, I can see the graph's going forever left and right, so our domain is all real numbers. And then our range, because the graph is going forever up and down, would also be all real numbers.